the most important thing you need to know is the website for the Envirothon has everything you need to know in there. The soils section of it, there's videos, there's links, there's resources, folders and tabs, everything you need to know and more than what I'm going to tell you. So be sure you use the website with your students. And the soils test in the contest is going to have 3 parts. 1/3 of the questions will cover the general soil knowledge. 1/3 of the questions will cover the pit that they've dug, and there'll be a teaching day like before the contest when you can go and see the pit, a test pit, an explanation pit, so you'll have a better idea of what the soils are in Capon, I guess it is. But 1/3 of the test is this notebook. In the bag at the pit will have a notebook with a map and a whole lot of information that comes from the soil survey, the web soil survey online, or it's based on the soil survey for each and every county in the state. So, you know, you can find yourself on a map, see what the map unit legend is, and then go and read about that map unit. There's all kinds of information, all kinds of tables and charts and interpretations in this survey, but it's also online now. Those are archival, those are old. Now it's online. Okay, so 1/3 of the test questions are going to come from that notebook that will be there at the pit. So you have to go over all that stuff that they're going to look up in the notebook as well. And the most important part is they have to be able to find themselves on a map. They're going to give you an aerial map, and it might be quite large actually. And the team has to find themselves on that map using landforms and landmarks. Because if they don't get on the right spot, they're going to miss a whole bunch of the test questions. That's the most important thing, locating on the map. I'll go over landforms. I guess I'll start out by saying the teams are going to rotate into the pit for like 5 minutes, whatever minutes they tell you. They only have that amount of time to get in the pit, see everything. That's not a very big pit. You're going to have a big pit. And they have 5 minutes or so to get in and look at all the things that you've taught them that they need to look at in the pit. And they get back out and they start working on the maps or the general soils information parts of the test. And then after everybody's had a turn in the pit, they can go in again and check stuff. But you'll need to train them to be able to jump in, get everything they need, and jump out within 5 minutes. And then they can get in later and check stuff. So to find yourself on a soils map, somebody gave me this map, and it's supposed to be Holly Gray Park, but it's not going to be much help because it must have been before the airport was built. Everything is different than it shows on this map. But they'll have a big map like this, and if you have a pond, if you have trees, if you can tell that it's on a hillside, top of the hill, down where there's a stream, you use all these landmarks and landforms to find yourself on the map. Because once you find yourself on the map, it's going to have the symbol for the different map unit symbols. Like this one says GUD, this one says VAD. The GU tells you what soils are in the map unit. The last letter on the map unit symbol name is the slope class. So they may not say A if it's level, but they'll say B if they mean 3 to 8% slope. They'll say C if it means 8 to 15% slope, and D is 15 to 25% slope. So it's important for them to find, that's one of the questions that's important for them to find where they are on the map, because they have to know what their map unit is to answer a whole bunch of questions. They have to know that map unit. And then they can go to the legend, and it'll tell them what that symbol means for the map unit name. And once they know the map unit name, then they start looking at the map unit descriptions that's in the notebook. And they also need that to know all the interpretations and charts that are in the book. They need to know the map unit name. Now, a map unit name can be like GU, which is maybe where we are right now, Gilpin Upshur. There's 2 kinds of soils in that map unit. And it's a complex because they just went ahead and mapped them together because it was difficult to separate out here, here, that the map unit lines would be way too complicated. So they mapped them together. And so the map unit description in the notebook will tell you all about that map unit, what soils are in it and what percentage of soils are in it. Very important that you're looking at the right one. And it's important to remember that that last symbol, that last letter in the symbol relates to the slope, because you may well get asked that. It's hard to show you a bunch of these things. Interpretations is part of the notebook. The page will look like, who knows what the page will look like, but like that map I just showed you, it'll tell you an interpretation, like this one is water, depth to the water table. Interpretations can be just a word like deep, very deep, not so deep, I mean shallow. They can be a map that shows you, you would have to look and see what the blue means, what the green means, but it would tell you how deep to water according to the colors. Or some of the interpretations have numbers, and it would tell you and assign a number for each soil series in the map unit, but then it will tell you what that means and what you would have to do to deal with issues with that soil, depending on what, you know, like if you were doing septic tank interpretations, it would tell you numbers, but it would also tell you if it was limited, very limited, or suitable for that use that you were going to make with it. So there's all kinds of different interpretations in that notebook, and you need to go over them with the kids so they understand what they can look up, what they can find out. That one was depth to water table, but this one's forest land productivity. And so you can go to site index chart and it'll tell you what the productivity would be for the different soils. And this one's hand planting suitability. You're going to be in a forest, so maybe the hand planting suitability is important for the foresters to know. Well suited or moderately suited, and it'll tell you why it's not as well suited. Slope or erosion or whatever, rock fragments. And another important one is land capability class. You guys don't have to remember all this because it's all on that website. But land capability class, LCC, each map unit is assigned a class, and it's very important for uses. Like 1 is prime farmland, no limitations at all. Number 8 is rock, just rock outcrop. There's nothing you can grow there but lichen. And then the numbers in between 1 and 8, as they go up, there's more severe limitations for uses. So 1 through 4 is good soil for crops. They might have a little bit of a limitation in 3 and 4 that you have to deal with, but you can crop them. 5, more likely hayland. 6 and 7 and 8, pasture. So the land capability class is important. There might be questions about that. So they could look up their map unit and look and see what the land capability class is, because it's very important for how you manage the land and the different uses you can do. Also, in the map unit description of that notebook, it'll have the details of a profile, like Gilpin, Upshur. There'll be details of the profile for Gilpin. There'll be details of the profile for Upshur. And some of the test questions may be that they have to look at that profile. What is the A horizon's color, or what is the C horizon's texture, or anything like that. So they need to know how to find that in the notebook. Soil scientists map the map units on landform. So part of the test might be on that, but at any rate, it's important to understand that the different soils and the different map units are on different landscapes and landforms. So landscapes you're likely to see are river valleys, hills or uplands. And then on those landscapes, there's different landforms. Like on the river valleys, you may see floodplains, terraces, and on the hills you're going to see like if we were at the bottom of a hill, which we could pretend we are right here, it would be the foot slope. And if you're further up the hill on the steeper part, that's the back slope. And if you're at the top of the hill, you're on the summit, of course, and just over from the summit is the shoulder. So it's summit, shoulder, back slope, foot slope. Those are important to understand too, because a lot of the soil's characteristics come from that. You have different soils on a floodplain than you have on a back slope. Way different. So most of those interpretations that are in the notebook are associated with a map unit, no matter how many soils are in that map unit. But the soil horizon that you look at is associated with one individual kind of soil. And we name them, and we give them a series name, which is easy, like gilpin. And we also give them a taxonomic name, which is, keying it out in taxonomy. So a gilpin is a fine, loamy, mixed mineralogy, mesic climate, typic haplodult, I think. So that you'll find that in the map unit description too, or in the notebook at any rate. So the interpretations go with the map unit. The horizon characteristics are associated with a soil type. And I was telling you earlier, the soil interpretations can be descriptive, like they'll say slight, moderate, severe. They can be visual, because you get different colors on a map, and it'll tell you, like red, that one's limited. Green, that one doesn't have any limitations. And it'll tell you which is what. And then sometimes it's numerical. They give you a rating between 0.01 and 1, and they'll let you know that 1 means it's very limited. 0.01 means not much limitations. So once you've got that notebook understood, and be sure to go to the website and look at all that information, the next thing is to look at a pit. And I only dug a wee little pit because we don't want to make a mess here. The first thing in a pit that we usually look at is the horizons. Have you heard about horizons in soils? We delineate horizons and then describe each horizon. So when you're looking in that notebook, there'll be an A horizon, a B horizon, maybe an E horizon in between, a C horizon. If you're in the woods, the top horizon is O, probably an OA, because that's the leaf litter. And then underneath that leaf litter, which is like blows away, so we don't really count that, there will be an O horizon, and you measure the depth of the soil from the top of that OA horizon. Or below that, an OA horizon is moderately deteriorated it's still organic matter, but it's been broken down. And then underneath that, there might be an OE, which is very broken down organic matter. The OA is, no, I said that backwards. OA is the most decomposed organic matter, and that's the one where you really want to look for that and measure that. So you start your measurement from the top of that and write down, you probably won't have to, but in the descriptions that are in the book, they'll say O horizon 2 inches or whatever. That's part of the horizon description. We count that in the measurements and so forth. Then if you don't have an organic matter horizon, which we really don't here because it's just grass, then the first horizon is an A. Makes sense. A, first horizon. A is the topsoil. And you have to be able, the kids in the pit have to be able to determine where the A horizon ends and the B horizon, or whatever's below it, begins. And so you need to teach them that the A horizon, they can determine where it is by color. Sometimes by texture, but maybe not. Definitely by color, usually by structure. Usually the A horizon will be the one that has so many roots in it. There'll be roots all the way down to wherever the trees can go, but there'll be a bunch more roots in the A horizon. And you can kind of see where that breaks off. And structure is an important thing in determining the horizons. Maybe I should just get to that next, though. One way to tell where the A horizon ends, see, it's very obvious in this one if you want to look at it. The A horizon has little granular structure. Underneath that it has subangular blocky structure. That's a different horizon. This bit at the top is the A horizon. You can see the roots, and if I would squirt it with the mister bottle, you would see that it's a darker color than the other soil. It's darker color because it's got some organic matter in it. If you're in a forest soil, you might have an E horizon underneath the A. E is for alluvial, not illuvial. And it means that the clay and the minerals, the nutrients have been alluvial. They've been translocated down. It'll be paler. It'll be a little bit coarser texture. It shows up as a pale, coarser textured horizon underneath the A. And it's just because the clay and the different things have moved down and they're not there anymore. Underneath that, which you may not have unless you're in the woods, we have a B horizon. B is the subsoil. It usually has more clay. It always has more development. It's going to have different structure than the A horizon. This one is subangular blocky, and I will go over that later. Then underneath the B, and there might be 3, 5 B horizons that we break out by different characteristics, but underneath the B there's a C horizon, and that's just unaltered, not much weathered soil that's come out of the parent material, the bedrock. It doesn't have any structure underneath in the C horizon. It's going to be a different color probably. It's going to be a different texture probably. And then underneath the C horizon is an R horizon. R is for rock. Now if it's very weathered rock and you can break through it with a sharpshooter or a backhoe, then we call it a big C, little r. It's a paralithic rock horizon at the bottom, CR. Or if it's hard rock, then it's an R. The horizons are named with capital letters, capital A, capital B, capital C, capital R. And then there are subscripts added to those to let you know different characteristics. Like if this soil had been plowed and there was a plow pan instead of just an A and an E and a B, if there was a plow pan over the B, there'd be a little P, it would be an AP for the plow pan. If the B had a significant increase in clay in the B horizon as compared to the A, there might be a small T, it would be a BT, and that signifies an argillic horizon with greater amount of clay. If the B horizon has a fragipan in it, a fragipan is a cemented soil layer. It's hard to dig through, it's hard for roots to go through, it's hard for water to go down through. So it's important to note if one of the soils you're studying in your notebook has a fragipan, because they might ask you about that. A fragipan in a BT horizon is a BTX. The X means fragipan. If you're looking at the soil description and you see an X, that means there's a fragipan there. And I can't really tell you how fragipan's formed. I'm not sure if anybody does tell you, they might be wrong. We just don't really know a whole lot about that. It's oftentimes in a soil that has been deposited from on a river terrace or glacially, or air. If the wind blows really fine silt over and creates a whole entire profile, you might find a fragipan in that. And for instance, our state soil, the Monongahela silt loam, it has a fragipan. Something to deal with, but it's a very good soil for hay. A fragipan, though, restricts the roots, restricts the water movements. It's something that you have to deal with, usually. So when you're looking at the horizons, an important thing to know is structure. which structure just describing the aggregates, what we call PEDs. The smallest unit of a clump of soil is a PED. You're probably used to clods. But if you kind of take a clod, break it down some, these units, the smallest units that come from that horizon, are PEDs. And you look at these PEDs and you can tell what kind of structure it has. These have a fairly rounded edges. They're not sharp, they're not angular. They're a blocky shape. This is subangular blocky structure. If we could get a hold of a good bit of the A, the structure is usually different. There's a piece of B, I'm throwing it out. You can see that this is what we call granular. They're smaller, usually. They're round. They look like little round bits of soil. This is called granular. Usually you find that in an A horizon, but I guess you could find it in other horizons. That helps you know when you come to the bottom of your A, because it's really obvious on this soil where the granular stops and the subangular blocky starts. In the B horizon, you might have angular blocky, where the edges are sharper, subangular blocky, where they're more rounded, platy, especially if there's been some kind of compaction, like from tractors. Platy is, as you would expect, a structure that's flat, kind of like leaves of a book. Not that thin, however, but they're thin and long, they're platy. And then if you have, I'm going to have to pass around a picture to describe columnar. Sometimes around here we have columnar structure. I think I better just pass a picture around. Actually, while we're at it, when you get down to the C horizon, there's no structure, structureless. It can either be massive because it's just a massive amount of soil material that's come from the rock underneath and it hasn't had time to develop structure in it, or it can be single grain, which means it's just a mass of sand. Sand can have single grain structureless structure. That doesn't make much sense, does it? The structure is very important to know because it affects the water movement down through the soil. If you have compaction on a horizon, the structure is compacted, less air, less water is going to flow down through the soil. And one thing that's important to know, tilling destroys structure. You can do no-till farming on a field for years, and you've got this great granular structure, lots of nutrients, lots of earthworms. Tilling it once destroys the structure. So why do we rototill our gardens? We probably should not. Do you have any questions about structure? Because I don't know that I really explained that. All right, another thing we have to look at in the horizons is texture. And, okay, this is important. Could be on a test, I would think. This is my opinion. Texture is defined by the percentage of sand, silt, and clay. That's all. They're not counting the rocks, they're not counting the organic matter. It's the percent of sand, silt, and clay. You all know what sand grains are. You've seen them at the beach or in your kids' play box. You can see those with the naked eye in your soil. Silt is a whole lot smaller It's you have to look at it with a little lens, a 10-powered lens, to see individual silt grains, and they're soft. If you have pure silt, it's like soft. It's like flour, sand, flour, and then clay. Everybody knows what clay is too. Clay is very dense. The particles, you can only see them with an electron microscope. They are so tiny. And so there's so many particles in a teaspoon of clay that it has a tremendous amount of surface area around each particle. It has a tremendous ability to hold on to water because the pores are tiny. Clay, if you try to plow it before it dries out, all you got is a big clod, because it just compacts into a clod. You got to be really careful with clay. Now you want some clay in your soil because it holds on to nutrients, it holds on to water, and it allows the plants to grow better. So sand, silt, and clay, it's kind of like sand is a beach ball. Silt is about, compared to the beach ball, would be like a tennis ball or a golf ball. And then clay is just a tiny little dot, like the end of your pencil, compared to the beach ball. But so the way we look at texture is we use a textural triangle. And you see, since it only exists with sand, silt, and clay, that's why it has 3 sides. And the 3 different kinds of particles have to add up to 100%. If they don't, you haven't created the right numbers. For instance, silt from 0 to 100, sand from 0 to 100, and clay from 0 to 100. So if you said, for instance, that you had 60% sand and 40% silt, you could go to this texture and look 60, going up to the silt line, 40. Where they intersect, you're going to know how much clay you've got, because that's the other line where they intersect. That's the clay line. In this case, 20. What did I say? 60, 30, 20? No. I said it wrong on the sand. 40% sand, 40% silt, then you know that there's going to be 20% clay, because that's what you've got at this little point. And what you also know is it's a loam. It's inside this polygon that has the name loam on it. So you can, if you have a soil and you texture it and you know that it has perhaps 70% sand and 10% clay, you go where those 2 lines intersect, and it tells you that it's going to have 20% silt, but it also tells you that it's a sandy loam. So we use this textural triangle to figure out what our texture is. But we also use, and this is on the website, both of these things, we also use a flow chart to determine texture. And you can practice this flow chart with your kids. It's a flow chart because you answer certain questions and it goes to different textures. If you hold it in your hand, moist ball of soil in your hand, and it will not form a ball, it won't stay in a ball, you've got sand. If you answer all these questions and come down through here, they'll take you to sandy loam, silt loam, clay, sandy clay, just by answering these questions about the soil you have in your hand. Okay, but the important thing for you to remember is how to ribbon that soil. Probably we should practice that a little bit. I don't know how time is, but ooh, maybe you guys will have to texture it at home then. But I'll pass it around. This is an A horizon. It's got to be moist but not drippy wet. And then you work it down so you don't have any more little lumps or rocks. Rocks don't count. Sand, silt, clay. Throw the rocks out, throw the roots out. But when you ribbon a soil, you take your thumb and you push it off the end of your finger. And you don't hold this part, you let it fall. When it breaks of its own weight, you look and see how long it is. That's maybe an inch. So on this flow chart, it's a loam. And actually, there's another question too. They'll ask you how much sand it feels like and how much silt it feels like. If it doesn't feel like sand or silt, then it's a loam. But this one's actually a silt loam, if you guys want to feel it. But it'll make your hands muddy. Use your non-writing hand. And so, if I took a sample from the lower horizon, I would expect it to have more clay. Sometimes when you have more clay, it's difficult to break them all down. This is the flow chart that you can find on the website. Has more clay, so it's harder to work up, but and if you're in the field and you've forgotten to bring water bottles, somebody's gonna have to spit on it.
That's COVID friendly.
Better bring the water bottles with you. You can put water in like a contact solution bottle or a water bottle with a little hole in the top. Well, that would leak in your car. Maybe if you just loosen the lid and use it that way. Okay, so when you make a ribbon and there's a lot more clay, you can hope to get, oops, I broke it. It needs a little more water, it needs a little more working, but if I would take the time to do that, you would, because there's more clay in it, you would get a longer ribbon. If you get a ribbon that's over an inch, you probably have a clay loom. If you get a ribbon that's 2 inches long or longer, then you have just a clay, a silty clay, a sandy clay, or a clay. This one came out at about 1.5 inches. It's a heavy silk loam. It's getting close to being, silty clay loam. It's close to being a silty clay. You can kind of tell that when you make a ball out of it. It looks like you have a little ball of clay. Do you guys have questions about texture? Here, you can look at this too. Or the back of my shirt.
Yeah,
We don't wear these to land judging contests. When you give too much hints to the children. So one thing that's related to texture, and you may hear this again, is the available water capacity. Available water capacity of a soil is how much water it's going to hold in it when water's run off or drained through. How much water is the soil still holding that will be available to the plants? Not all the water it holds, because it holds tightly sometimes, is available to plants. But the amount of water in a soil is closely linked to its texture. You may see that again. So the available water increases as the clay in a texture increases until you get to pure clay. And then it might just hold all of its water and not give any up. If you have sand, sand has large pores and the water tends to go straight through. So there's less water in the soil, there's less available water in the soil. If you have a whole bunch of rock fragments, that usually reduces the available water. It's because rocks aren't. They don't have any, so they're taking up room in the soil. There's less water available. If you have organic matter, like in the top horizon, a nice strong structure, and what we call PED stability, it hasn't been tilled, it's got strong structure, then you're going to have a lot better available water capacity. And that's why the A horizons is where we grow most of our crops and flowers. I talked earlier about landscape and landform. The landscape usually determines what parent material you have. On uplands, on hills, at the top of hills, your parent material is going to be residuum. It's the rock that was there on the top of the hill. It weathers, it has different forces acting upon that rock. It becomes soil, and gradually the soil gets structure and texture, and it becomes a nice soil profile. A young soil doesn't have much of a profile, just like the A horizon and the C maybe, and then the rock. But on top of the hill, it's residuum, residual soils. It comes from the bedrock. Down in the river valleys, on your floodplains and terraces, it's alluvial parent material, deposited by water, streams, creeks. Deposited by water is alluvial. And in between, on a slope like this one, it's called colluvial. Colluvial. It's affected by gravity. The soil has blown, washed, or just by gravity tumbled down the hill. It's from the top. It doesn't usually go uphill. It comes down the hill. It's colluvial soil. There's two other things, but you probably will not see it at Kakapen. Windblown silt is called loess, and windblown sand is called aeolian parent material, but you probably won't see any of that. If any of you are over like east of the Ohio River or any major river, or where the glaciers were, a lot of times when the glaciers receded or the water came up and then went back down, the wind will pick up sand and blow it in the direction of the prevailing wind. So usually it's on the east side of that river. Or silt. Silt is very light, and it will blow off before the sand does because it's so light. And so you'll have a lot of silt in the soils east of that point. You probably won't see those around here. Maybe up in Morgantown, maybe. Parkersburg. One thing that when you're on the top and you run into rock, bedrock, residuum, when you're on the river valley and it's alluvial, deposited by water. But colluvial is a little bit in between. One way you can tell is the fragments. This soil had quite a number of fragments in it. We stacked some of them right here. And there's one right at the very front here where it's a big one and we didn't dig it out. But the fragments in colluvial soil, can you see how sharp, Can you see how sharp the edges are on this one? And this one's fairly sharp. It's a little bit rounded. Oh, sharp. But another way you can tell colluvial deposited rocks is they're jumbled. They've rolled down the hill. They're mixed up in the soil. When you have a residual soil, the rock fragments you might have found in there are usually horizontally layered. That's a good way to tell colluvial soil. Rocks tumbled and angular. The alluvial rocks will be rounded. They've been worn by water. They'll be rounded. And the ones that have just come out of the bedrock, they're more likely to be angular because they haven't had a chance to tumble down the hill and get worn down. The next thing perhaps is the pH kit. Has anybody done pH kit? No. Yes, no? No. I think they'll have this kind at the pit. Perhaps this is what all of my colleagues use. You have a little tray. You have a little stir stick. Wipe it off between each cell. And you have two reagents. This one you put on and mix with the soil to make a solution, a paste. And this one you put on after that so that the color of the solution will show up. You can't really see it against the soil. This will make the colors show up. So, do you want to come and try one? Then you have this little card that you compare the colors to figure out what your pH is. And it's only going 4, 5, 6, 7, 8. So you have to estimate the 0.1 part. 7.5, 7.7. Don't try to get too accurate. This is the A horizon. There's dirt in that one. Did I say dirt? Naughty, naughty. You put about this much soil in the well. And then, can you take the lid off? Put at least 2 drops in each one and we'll look at it more. I put too much dirt in.
Keep going.
Yeah. Okay. Try that one. Okay. And then I'm going to use the stir stick, and I might have to put some more of that on again. But you just stir it around a little bit. Mix it up. And then you kind of push the soil to one side so that solution will go to the other side. Maybe I don't have enough in this one. Just
More
one,
of both?
just one.
And this one.
Yeah. You're supposed to wait 2 minutes. I don't have a watch, but this isn't, we're not going to record it anyway. Take some, okay, this is important to know. The little rubber cap lifts straight off. A lot of times people will try to twist it off, the whole top comes off, and they have their powder everywhere. You look like you've been baking with confectioner's sugar. So the little rubber cap lifts straight off. And this is a normal thing. Can you see any coming out? No. You gotta be near something that you can tap it on. Your boot, a rock, shovel. I don't know why, but this indicator almost never comes out well. Only when you're tapping it, right? Maybe we want to take the lid off. But the powder has to be thin. If it's caked, you won't see the color. So don't be upset if your powder doesn't come out. This is normal. And so it's probably been part of the 2 minutes already. And then you simply have to compare it to your card. This was the A. Can you tell what color it is?
One of your greens here. Would around 6 be?
I'm thinking 6. Yeah.
Is that what you're thinking?
Yeah, 6. So we had a 6 on the A horizon. And the C, it's not nearly as yellow as I thought it would be.
So around a 5?
Yeah, a
5
little
and a half.
over 5. So it went from a 6 to like a 5.2 or 3, 5.2 or 3.
Is it typically, the pH, does it typically lower as further down you get?
That's a good question. She said, does the pH go lower as you go down? It can vary a lot, but yes. The leaves, the grass, the earthworms have left nutrients in the A. So generally the A horizon has a bit higher pH unless you're under pine trees. And then all those pine needles are going to lower it. And if you get down to the bottom and the pH changes, that's because it's still close to the bedrock. Like you might have an acid shale bedrock, you might have a calcareous shale bedrock, and that will really change the pH of the soil, the parent material. Forgot where I was. Bulk density might come up. Bulk density is weight per volume. If you had a chemistry class or a physics class, weight per volume. So the soils can vary a lot in bulk density just because they're sand or silt or clay. And also if they get compacted, if they're compacted and you take this much soil and make it like that, of course the bulk density is going to be higher. It's much more dense. So that's another reason you don't want a compacted layer. Usually clay is a lot heavier than loam. I'm not going to say it's heavier than sand because wet sand's pretty heavy, but if you have a loam and you have a handful of clay, the clay is going to be heavier in bulk density. Water moves more quickly through the sand than in a heavy soil because of the pore spaces. We didn't do color yet. Do we have much time?
It's 11:47.
Okay. Color. Okay, so in the color book, which I will show you, and there'll be one at the test pit. I don't know how, if your schools have them or not. To buy the whole book is very expensive, but a lot of times you just buy like the 3 pages you might likely to see. The page, each page in the color book shows the hue. There's a red hue, a yellow hue, a red-yellow hue, a yellow-brown hue. That's the page that you're on. And then on the left-hand side going up and down is value. And value is how light or how dark the color is. Like at the top, it's going to be like white. At the bottom, it's going to be like black. The value changes, gets higher. As you go down, it gets darker. I said that backwards. The value at the bottom of the page is the darkest, and it's also the lowest number. And then as you go across the page, that's chroma, and chroma is a measure of brightness. So on the left-hand side, where it's low chroma, it's kind of a matte color, kind of grayish color, and as you go across, it gets brighter and brighter and brighter to be bright colors. When you check your color in your color book, you're supposed to do it with the sun over your shoulder, so it's shining on your color book and on your color. Sometimes there's no sun, and you have to do your best. One thing to know about color is organic matter makes the color of the soil darker. Like your A horizon is a darker brown, it's because of the organic matter, usually. The color of the rock it comes from can affect it too. The matrix color of horizons, the background color of a horizon like that one, it's affected by the iron oxides. Iron oxides, iron in many forms. The colors are bright in a well-drained soil because there's iron there, different forms of iron, and it's oxidized iron, rusted iron, so it looks redder or browner. But if you have, and the natural color of mineral soil is like white or gray. Natural minerals don't really have color. So what you're seeing there is different kinds of iron and other things, other chemicals held onto this sand, silt, or clay particle. Now, there's likely to be bright colors in there that came from the rock. Like if you have a rock with red and yellow in it, there's likely to be some shades of, I saw some, I don't know where they are, but you can see it like, well, it's dry, so you can't see, but there's some bright yellow mottles in that pit that came from the parent material. There can be coatings from the upper horizon that come down, like organic matter, clay, silt can coat the particles below it, and so changes the color. But then you get into redox concentrations and redox depletions. And this is what you'll find in a wetland. Wetlands are anaerobic. There's no oxygen. If they're really saturated with water for most of the year, that means there's no oxygen most of the time. And so the iron gets reduced, a chemical reaction where it's reduced. So you have iron depletions are gray or white. Iron concentrations is where they depleted, and then the water went down, got some oxygen, it rusted, and so you sometimes see red spots, red specks, small red iron concentrations in a hydric soil too. So I said they were anaerobic. That means there's just little or no oxygen that can chemically react because the pores are full of water. And that's when you have a hydric soil. But just having a hydric soil doesn't make it a wetland. If you're going to call it a wetland, you have to have hydric soil and hydrology, wetland hydrology, where there's water, like you're stepping in it, water. And also it has to have hydrophytic vegetation. I've seen some here, actually, even though it's up on the hill. But there are plants that will only grow where it's a hydric soil. That's their natural spot. And if you find those plants there, it's called hydrophytic vegetation. That's part of calling it a wetland. You have to have the vegetation and the water and the soil to be hydric. So these waterlogged soils often have gray colors, especially at the bottom. They can go all the way up. But depending on where they're predominantly gray, that's where we say the water table has been. If it's predominantly gray, the water table went up that high. You can have some gray above it because sometimes the water table goes up and down. And a well-drained soil, if that hadn't dried out, it would be bright colors. There's no redox there. It's well-drained. And so, depending on where you see the gray colors, and this is in your website, depending on where you see the gray colors, you can determine the depth of the pit where they come in. You'll know whether it's very poorly drained, moderately well-drained, well-drained, depending on where you find predominantly gray colors. So I didn't really mention infiltration and permeability. The better your structure, the less compaction, the lower bulk density means you have better permeability. Okay, so infiltration is water coming down the hill, hitting this spot and going in. It's not runoff, it went in. That's infiltration. And the texture and the structure and so forth of your soil determines how much water is able to run in before it runs off. Now permeability is within the pit. The water that has infiltrated is now going down the pit, and that's called the permeability, how the water's moving in the pit. Those could come up in your contest stuff. So the lower bulk density would have much better permeability. If there's a lot of rock fragments, there'll be much better permeability because it just goes right down through those voids that they create. Maybe I should have said at the beginning, but there's 5 soil forming factors. And you're going to see this on that website. They go into the 5 soil forming factors. As this is what we say all soils experience. We've talked about parent material, which is alluvial, residual, colluvial. And we've talked about landscape, which is hills, uplands, or river valleys, and others, which we don't have here. Another one is climate. Climate is a very broad effect. You know, the climate is not going to change from this pit to one over there. Climate is very broad. Another one is organisms. Worms is a big thing, all those little bugs. But beyond that, microbes. You know, there's millions of microbes in just a little bit of soil. All those things help form the soil and, you know, create nutrients or nutrient availability. Usually the organisms recycle nutrients, which, you know, they come back to the soil. And that decreases erosion. It's always good to decrease erosion. The last one was time. As time increases, the soil development increases. Eventually soils become leached or more acid or more clayey. For instance, you have a young soil just on a steep hillside or down near the terrace. It's just been formed. It hasn't had time to develop a whole lot of structure and different parts of the profile. However, an old soil will have a much better structure, but it might also be very oxidized. It might also be very leached. So time really affects the soil. Erosion too. Erosion as part of time. It's not a separate class. I'm assuming that when you go to Cacapen, you might have a lot of forest land versus cropland, which is where a lot of West Virginia's agricultural soils are, is cropland. Trees like it more acid, like about 5.5, I guess. Crops want it higher than that, about 6.5 for most crops. There's, blueberries want it lower. The most nutrients are available in between pH of 6 and 7, 7 being neutral. They're much less available if you get too basic, and they're much less available if you get too acid. So it doesn't matter if you put fertilizer on. If you need lime too, that fertilizer is not available. And the 3 macronutrients you might need to know. Every complete fertilizer is nitrogen, phosphorus, and potassium. Those are the macronutrients that are important for soils. But there's a gazillion little micronutrients, and like zinc, boron, manganese, molybdenum, and just a lot of them. And some crops need more of one of those things than others. So you might have to add that in a fertilizer. Your soil might be low in that. And a soil test will tell you. And anybody can do a soil test. They're still free. I've heard rumors that other places are charging, but they're still free at WVU. You just have to mail your dried soil samples to them, and they will email you back the results, and also some information about what you need to know for your soil, like lime and fertilizer and so forth. Or you can ask your local NRCS office to give you some interpretations on it. So the one thing I was going to mention, I mentioned once before, the state soil. You may see that again. The state soil is the Monongahela silt loam. You can have Monongahela's sandy loam, I guess, but Monongahela is the state soil. It's very important in our state because it's got that fragipan in it, but it's useful in a lot of places for hay, pasture. So it's an important soil in our state, and that's the one they picked to be our state soil. I think they're going to talk to you about the 5th topic, so I won't go on that because I don't know anything about it. And the one thing left to do is to show you how to use a clinometer. Anybody know? I guess when I was talking about the hydric soils, I meant to give you a picture so you could see that, because I can't show you here at this pit. And there's also this one that shows you the state soil. And what else we got? These things you'll find on your website anyway. The landforms, what you're going to look for in the notebook. But slope. I have 2 slope stakes. They'll have a clinometer at the contest tied to the slope stake, maybe to both of them. At the contest, the slope stakes are going to be the same height because they want you to measure exactly and be able to tell them what the slope is. These I just hit in with my hammer. It doesn't matter because we're just going to practice shooting with a clinometer. We do slope in percent. You can also do it in degrees, but we do percent. And so to do, well, okay, a 10% slope means if you have 100 feet, the ground is going to rise 10 feet for every 100 feet, 10% slope. So with a clinometer like this, you hold this end where the string is, where the little knob is, and you keep both eyes open. This might take some practice, but you keep both eyes open, and you look through this hole. This hole is for sighting. Look through the big hole. And so when you look through the kilometer, you're going to see a line going across. And you want to look for the top of the stake with one eye. Look at the line inside the clinometer with the other eye. And if you're shooting at the top of the stake, where that line is from where you're standing, and you would have to stand at that stake and shoot at that stake. But where the line is, it tells you what the percent slope is. However, it's also telling you what the degrees are. So it's very important that you take your clinometer and go way up. At the very bottom of the scale, you'll see a percent sign. So on this clinometer, percent is on the right. But not all clinometers are like that. So it's kind of important to check. But I think anything at the contest will have percent on the right. So you can put it at the top of a stake. They might be taller there. And you make the line that's inside the clinometer line up with the top of your other stake, which this is about a 10% slope. Does anybody want to try it? Probably you should. Right, there's my problem. And if I only had two, which technically I do, what we do mapping soils is we check it both ways, uphill and downhill, because it's going to vary a little bit and we kind of take the average. It might be 2 or 3 degrees off from uphill to downhill, and we just average that. So you might want to tell your students to do that as well.
So the stakes have to be the same height? Is that what you said?
At the contest they will be, because you want a true slope of the ground. I didn't bother measuring them here. And if you don't want to kneel, you can. We're not doing a contest, so use your eye. Try to keep both eyes open and aim it at the top of that stake. Or if we had a person down there, we do that in the field a lot. You find somebody you're working with and you say, "How tall are you?" You either aim at their eyes or up or down, depending on how tall they are.
The line on the top of it.
Right, at that line on the top of the stake, and then what does the number on the right say?
Oh, it looks like about 15, maybe
15?
Yeah, but I'm standing up.
Oh, that's right, okay. Yes.
So what is
How interesting.
I was seeing about 10.
Okay, that's what I saw.
Okay, good.
But I'm also never been good at that, so.
Well, make the students good at it. And on the test, it's probably not going to be a number like 10. It's probably going to be a slope class. Like, remember I told you a GUC? The C stands for the slope class. C is 8 to 15% slope. They might give you a range like that, 8 to 15, multiple choice, 2 to 8, 8 to 15, 15 to 25, whatever. So there'll probably be a range, which it makes it a little easier. And also, the person setting up the stakes probably won't make it near the line. They won't make it 8, because it could be 3 to 8 or it could be 8 to 15. They probably will put it in the middle somewhere, somehow. They'll rearrange the stakes to make it so. Is there anything else? Got questions?
I wondered about what you were talking about, no-till farming, how the structure of the soil is destroyed.
Right.
Does it continue as tilling continues? Does it further deteriorate, or does it just reach a point where it...
Yes, it further deteriorates, but you've done a lot of damage with just one tilling. I used to till my garden, but we should not. We should be doing no-till, mulch, newspaper, some kind of mulch, and plant through it instead of tilling it under. Cover crops.